We're going to do a session called Do Exchange Right or Move to Office 365. It's just a really kind of a catchy little title there. But what we're really going to talk about is a lot of the information about with the PA we say, oh, you should absolutely do this, this, and this. But there really is guidance out there on how you can do a few other things as well. And so we're going to talk a little bit about some of that guidance today. My name's Robert Gillies. I'm a senior architect in Microsoft Services. So what I do is I go out and I help our customers in the U.S. public sector deploy our technologies, Exchange, some other on-prem stuff, some identity stuff. Office 365 is a big piece of what I've been doing lately. And this is my cohort, Boris. Boris is a principal consultant. What else do you want to say about yourself today?
Well, I'm a principal consultant with MCS. I've worked there for 12 years for now, and I had worked with probably about 70 customers. I lost the count, honestly, ranging from a few hundred seats to 700,000 seats. So sort of accumulated some experience, and I think I understand now the value of the best practices in the Exchange world, and this is something that we're going to share with you guys.
So as we look at our session objectives and takeaways, what we really want to help you do is understand that preferred architecture, but also kind of understand why we make those recommendations. But then we've got some typical challenges and misconceptions around some of those recommendations. And we do have some good other ways that you can deploy Exchange. There's guidance around things like SAN. We do have guidance around SAN, but you need to think about some things very similar to things you have to think about for the preferred architecture. So we want to talk a little bit about that kind of stuff. And really the bottom line is the more simple you can keep your solution, the better off you are. And if you can't do it right, we really think you need to consider Office 365, right? And that doesn't mean necessarily if you're going to end up on a SAN or virtualization, you're not doing it right. But you need to do those things right as well. So, Boris?
So before we start all this and switch to the design principles and understanding preferred architecture, let's do a little bit of a show of hands. So please raise your hand if your customer is currently already in Office 365, if you are in Office 365. How many of you here? Okay, not so many actually. I expected more hands. How about those of you who are on premises? Just to check if you guys are paying attention, right? So, okay, that's significantly more, and this is probably the reason why we have you all here. This session is about on-premises.
How many of these on-prem customers are on SANs? Virtualization. Yeah, so there's an awful lot of customers out there doing those things. So.
Okay, so I was about to ask a question. How many of you are firmly confident that you are deploying Exchange right, following the preferred architecture principles? But I got a feeling that this question is now rhetorical based on the questions that Robert just asked. So, this is really, this nice little picture is the ultimate answer to what our preferred architecture is. In a way, that's a joke, but you should understand that how the product was designed, how the PG was thinking about the product for the last decade is mostly based on how would we implement it there in the cloud, and it was really designed to work best there. So the way how it's designed and implemented in the cloud is the way how we would like you to deploy this on premises. Now again, we keep speaking the cloud, but it's really the on-premises that is the main topic of our presentation.
So we got a lot of feedback. We do a similar presentation to this inside at Microsoft, and we got a lot of feedback that we need more on-prem Exchange sessions. And this was actually from one of our feedback forms. Now, someone can't post that in there, but this is the way we feel. We come up and we do an on-prem session, and people go, oh, we need more on-prem sessions. And but we just did an on-prem session. Why are you telling me you need more on-prem sessions? But So Boris likes to say that since it says more on-premise exchange, that it doesn't matter if they misspelled exchange, it's on-premise that's the bad thing here, right? It's on-premises. We see that a lot, but whatever, everything's misspelled on here.
Yeah, but it's a small spelling mistake, right? If you say on-premise instead of on-premises, despite it's completely different words, it's okay, it's not a big deal. But if you do something wrong with your Exchange deployment, then that's probably a big deal, and that will bring you some harm in the future. So we do understand that not in every environment and not under all circumstances you can follow the best practices and deploy everything exactly the way how Microsoft advises you to do that. So sometimes you don't win your battles and you have to do something wrong. And you know what? There are so many of these cases that we actually thought of renaming our presentation.
Yeah, we had some alternate names.
And instead of calling it Do Exchange Right, we thought to call it like this. In other words, we want you to deploy Exchange in a way that will hurt you the least.
So we talked to the product group an awful lot, and I think Boris and I both are firm believers that the place we start discussions with customers is the PA, right? But Boris and I work with customers. We work in the real world. We can't be divorced from the fact that we go out in the real world and we're not going to win that battle every time. When we come in and say, you shouldn't do it on sand, some of our customers are going to say, yeah, we understand that, but we're going to, right? And so as far as what the PA says, that's wrong. But we understand that we have to do that on sand sometimes, or virtualization sometimes. And what we need to do is keep some core tenets in mind to make sure that we cause ourselves the least possible amount of pain when we do these things that are quote unquote not right, right? We understand that not everybody's going to do it exactly the way the PA says, and that's what this session's really all about.
So where is the right answer, right? From what we already said, you realize that there are way too many options, and all of you know that, how you could deploy Exchange, how would you design your infrastructure. What's that guideline? Why do you need to follow that preferred architecture as it is laid out in Ross's article on the ELO blog? Why that way? We believe that there is a logical explanation of this, and this logical explanation is the design principles and the architecture of the product. What is the product group thinking when they were putting together the product, when they were designing it? Gives you understanding of what environment it will work best with. So let's try to dive a little bit into those design principles and try to understand how the product is architected. And then we will switch to the typical design challenges and try to understand how would you approach this or that design challenge based on these design principles, okay? So first, let's take a small trip down the memory lane and remember what was happening, Jesus, it was 14 years ago, 15 years ago, when Exchange 1003 was coming out. It was the great application, don't get me wrong, but it was not capable of a lot of things, right? It was a nice, decent, solid enterprise messaging solution, but it depended a lot on the hardware, on the infrastructure that you were deploying it on. Great example was the storage performance. Exchange 1003 needed a lot of disk I/O because it was very disk I/O intensive, so you could not just deploy it like on floppy drives.
How many of you remember having to calculate how many IOPS you were going to use? Because we didn't really have a good calculator at the time, right? It was hard, wasn't it? So we've actually done a lot of work around that, not just on the side of reducing that number of IOPS, but giving you tools to help you figure that out, right? So we've made huge strides since then.
And IOPS is just one example. You had to deploy some decent infrastructure to address redundancy of the components, like what happens if the disk fails, or some hardware component fails in your solution. You had to ensure that your messaging service is still available, and that's why you were deploying the SANs and RAID arrays and all that kind of stuff. Bottom line is the brain of this solution was mostly on the hardware portion of it, on the infrastructure. So it's been a long time ago. Now today, since 2010, 2013, now 2016, and 2019 is looming on the horizon, right? The brain has shifted into the software part of it, into the application. Exchanges now provides a lot of capabilities out of the box, including redundancy, which is probably the best example with the database availability groups and multiple database copies that could automatically fail from one server to the other or even from one data center to the other. That's where the brain of the solution is. And it's very important to understand that all this functionality you get just with the product, which means you don't need to invest in some fancy schmancy infrastructure and to provide the same functionalities out of the infrastructure, because that will be like a duplication of effort and extra expense. So I said redundancy, I said availability. Let's try to summarize what are the cornerstone fundamental design principles. And actually this slide is sort of a key, and it applies not only to Exchange, it applies pretty much to any enterprise solution that you are building. You must provide these 4 cornerstone things for the solution: availability, functionality, operations, and cost. Who needs the solution if it's not available, if you cannot use it, if you cannot connect to it and get what it does?
How many of you get to start a project when cost is not an object? We know that oh, we got more money than you can spend. Just go do what you need to do. So, I saw a hand. I saw a hand in the back.
So each of these 4 cornerstone principles is critically important. And what I am driving at, cost is one thing, operations is the other thing, but naturally, from inside the product, we are trying to address the availability and functionality principles. And when you start talking about availability, it's very important to understand probably three main ideas. So the first idea is that complexity of the solution actually drives availability of this solution down. And it's not something like a gut feeling, it's the pure math. And I like to dive into that because if you use the terms of the probability theory, it's very easy to understand why this is happening. So in the hypothetical example, imagine that you have a solution that consists of 2 components, component 1 and component 2. Doesn't matter what it is, like, I don't know, Exchange server and storage, or I'm intentionally going simple, right? Just 2 components, 1 and 2. Each component obviously is not always available. It has certain availability level, which is, as all of you know, measured in the percentage. So let's say, for example, that each of them has availability of 90%. Now, for the entire solution to be available, you need both of them to be available simultaneously. From the probability theory, that means you need to multiply this probability number. So 90% times 90%, it's 81%. So your entire solution only has availability level of 81%. Easy to understand that if you add more components to the solution, your overall availability will go further down, right? So the more components you have, the lower is your availability. That is math. You cannot argue that. So that's why complexity is bad. It's just basic math.
I forgot to mention earlier, Boris actually used to teach math when he lived in Russia. So anytime anybody needs to talk about math, as far as this is concerned, we always go to Boris. Nobody understands this except Boris. So if you need to email him, let us know. We'll find him. We'll get him online. You can ask these math questions again.
So that's
or just steal his slide and use it.
So that's one of the reasons I'm standing here on this stage. I want all of you guys to understand it as well. And it's really not a rocket science. It's just, 90% times 90%, that sort of thing. Now, the other thing here is redundancy. So to increase this availability level, we ensure that each of the solution components is deployed in several identical copies. Let's say like 2 database copies, for example. Or, I don't know, RAID 1 mirror, which contains 2 identical hard drives, right? So let's say you have 2 components. Now, for this solution to fail, you need both of these components to fail simultaneously. Not to stay online simultaneously, but to fail simultaneously. So the same mathematical statement now applies to the probability of failure, not to the probability of staying online. So it would be, obviously, probability of failure is 10%, so 10% times 10% is 1%. So the remaining is 99%, and that becomes the availability of the solution, which contains two redundant components, right? So there are two different directions. If you increase redundancy, you improve availability, it goes up. If you increase number of independent components in the solution, availability goes down. So it's important to understand these two principles.
So this is why we go in the PA with 4 copies, right? 4 independent copies of the data. Yes, you've got the component of a non-rated disk that has a higher percentage of failure than a rated set of disks, but by having 4 independent copies, when you get down to that bottom line and start multiplying across there, that's where you start getting up in those high 9s of availability. And that's really why we talk about why we need to have 4 copies.
Last important principle here is the failure domain. So these redundant components are okay, but if you put all of them into the same bucket, if you will, in the general sense of the word, so that they stop being independent, then that's bad. For example, the same two hard drives are connected to the same RAID controller. So if that RAID controller fails, both of these hard drives go out, right? So your redundancy goes down the toilet. So failure domain is this area where redundant components are grouped together so that they stop being independent from each other. So you lose, in a way, you lose the redundancy here. So this is bad. Having failure domains drives your availability down. It's really easy to just always remember these 3 principles, right? Complexity is bad, redundancy is good, failure domains is bad. And just follow this guidance when you do the design. So now the typical classical enterprise architecture model is based on the shared infrastructure. You deploy this large enterprise-grade storage solution, the SAN, that is supposed to carry all of the workloads from your enterprise. So you concentrate all this storage operations into this one huge infrastructure block. You deploy your Exchange servers on the blade servers that are all part of the same chassis. You deploy your Exchange in the virtual machines. All these virtual machines are sitting in the same physical host that is actually in turn located on one of these blades out there. You see how this leads to an enormous amount of failure domains happening like at every stage of the solution, right? All these virtual machines are sitting on the same host, so if this host fails, you have a problem. Now you need to address that problem. Now you start adding features like vMotion and queue migration and other fancy words, and it just adds complexity to your solution, which drives availability down. Same could be told about the blade servers connected inside the chassis because they are all sharing a lot of hardware components on the backplane, the virtual network card, and other stuff like this. Same could be told about the SAN because it critically depends on the cluster heads, on the controllers there on the SAN, on the fiber switches that you put in your environment. A lot of excessive hardware components that you depend on, and all of this drives your availability down. So this is not how Exchange was designed and thought of since at least 2010, if not earlier. Exchange is using a different architecture principle, and that's important to understand. It's a fundamental difference. It's different architecture. It's the building block architecture. Instead of relying everything on the huge but single enterprise-grade infrastructure element, let's do completely different thing. Let's deploy it in multiple, independent, isolated hardware islands, like each server is an island. And these servers, these pieces of hardware, are totally independent from each other. So if one of them fails, we don't care because there are others that are available and they would continue to carry the load. Granted, you have to have a mechanism that would allow you to switch the load from one building block to the other building block when bad things happen. So your application, your software must be capable of doing that. And this is exactly why all these ideas and this architecture was not possible back then in 2003, because application was simply not capable of doing things like that. Now, with the latest version of Exchange, when all of this is inside the application, is built in there, that is the architecture model that we follow in Office 365, and we would like you to follow on premises.
So we're getting a little behind to where we need to be. So I don't want to spend much time on the PA or the PLA. So the PLA, if you come to Microsoft and get us to come help you, MCS to come help you deploy, the PLA is kind of our, we wanted to call it a reference architecture. There's reasons why we can't do that, but it's our architecture that says we think this is the best way to do that. And we have guidance that goes outside of tight PLA deployment, so we have SAN guidance and things like that. But so there's other sessions this week you could have seen the PA, but let's just say for this slide that MCS would come in and we can help you deploy and get as close to the PLA as you want. Now I see someone out here taking pictures. You know you can download our slides if you want, okay? So if you want to take pictures, that's fine, but just do remember you can download the slides.
So now I think we have some slides shuffled slightly in the presentation. Let's see if...
Did something get moved?
No, I believe so.
I think one of our slides got moved around. Boris is kind of fixing where the slide goes.
I think that should be it.
Yeah, so we're going to jump into addressing design challenges. So one of the things, I mean, if you've ever seen me present, and I know Boris does the same thing, is we talk about simplicity. I am very risk averse in the projects I work, and I'll come in and I'll talk about every time you bring a risk in, every time you bring a complexity in, it brings a risk to the project. And that risk to the project is a risk of you and I being successful in our project. And so we talk a lot about this idea here, the Confucius saying of life is simple, but we insist on making it complicated. Exchange can be very simple. So when I come into a project, one of the things we'll do is we'll start with that PA. And when you want to bring a complexity into the project, I'll push back on that. That doesn't mean I'm telling you can't. It's saying, let's prove the fact that we have to bring that complexity in, right? And so that's really one of the stances I take a lot. And so as we start talking about design challenges, a lot of times those can be looked at as complexities. And remember that complexity brings risk to the project, and that's why we push back on them.
And again, remember that anytime you're addressing design challenges, your guidance and the thing in mind should be always Office 365.
One of the things we found is the Office 365 team deploys Exchange and all the other capabilities out there in as simple a solution as possible so that they can guarantee the availability that they have in the licensing agreements, in the SLAs, to say this is what availability will have. And so they really live by that simplicity design as well.
I've been on vacation in Italy a few months ago, and this is the picture that I took in Vatican in Rome. So you see, even they understand the importance of Office 365 out there. Anyway, so let's jump to the design challenges, and we tried to group them into several categories, starting with the most painful ones and trying to follow and kind of help you make the right design decisions. So probably the most painful design battles are around the storage design. And Exchange storage design is usually not as simple as what we show here on this picture. So let's try to understand what are the challenges with the storage design. So easiest way to understand it is there are 3 independent dimensions in the storage design solution. So you need to make 3 different decisions. One dimension is complexity. So you need to decide how complex your storage solution needs to be. Usually it's the choice between the SAN or DAS. And the SAN is an example of extremely complex and extremely robust and reliable and scalable, all that kind of stuff solution. And DAS is an example of the simple solution, and that is its biggest advantage, that it is simple. There are no extra elements there in this solution, which makes it easier to maintain, operate, and in the end of the day, that means better availability. So that's the key. Second dimension is redundancy. So you have to choose whether you use different flavors of RAID, or you just deploying Exchange on the JBOD, which is our best practice. Again, the key concept to understand here is that Exchange provides redundancy out of the box in the product itself at the application level using the database copies. You can think of Exchange as an application level RAID that kind of synchronizes your data between different servers, and it can maintain not just one, but 2, 3, 4, whatever number of copies. So it's actually quite advanced RAID concept. Finally, the last dimension is the performance. And here you have a choice of deploying Exchange on the slow SATA drives or the fastest SSD drives or something in between. And the key guidance here is usually to understand what your business needs, what your deployment really needs. Do you need capacity more, or do you need performance more? And there could be all types of cases around there, but usually the overwhelming tendency of the last years is that we need capacity. We need large mailboxes. You know that Office 365 gives you 100 gigabytes mailboxes. So large capacity is critical usually for Exchange. Performance, on the other hand, is not. Even the slowest possibly available disk on the market today, the 7200 SATA drives, they can deliver more than 70 IOPS per spindle. If you do the Exchange design, and I've seen a lot of them, and usually typical Exchange 2013-2016 database requires IOPS, max 15. Think about it. You need 10. The slowest possible disk gives you 70. Isn't that enough?
Yeah.
Why would you need to go for the disk that gives you 250?
Yeah, the thing to remember there is, though, if you start designing your system thinking, I want really small mailboxes, I'm going to give my users a gig or 2 gigs of a mailbox size, and I want to cram more users onto a server, that will start driving those IOPS up on how much you need them per disk. And that's where customers will come in and say, well, we require a SAN. It's because they're going with those really small mailboxes. Remember, Office 365 is giving 100 gig mailboxes out. That's really where Exchange is designed, is around those really large mailboxes. Most of our customers, the users, are really pushing for those large mailboxes. You got the smaller mailbox, the users end up having to manage those small mailboxes. So Exchange's sweet spot is really around those really big mailboxes, and that drives the direct attached storage that Boris was talking about. It drives non-RAID, it drives SATA, or most of our customers won't go with SATA, they'll go with a nearline SAS, right? So that's the core spot where Exchange was designed around. That doesn't mean you can't have RAID. It doesn't mean you can't have a SAN. It doesn't mean you can't go with the faster storage. We have a lot of customers who are successful doing that, right? And we do have guidance around that. But I mean, Exchange's design really is around that core sweet spot.
So we understand that there could be other arguments, non-technical ones, like we just purchased this shiny GlobaSAN 3000, always available Elite Pro, that we need to use, and we paid millions for it because it never fails, right? It never fails because we paid millions for it. So you have to use it for Exchange. Sometimes there are those battles, like we said, that you cannot win. So if you have to use the SAN, what should you pay attention to so that you don't let that SAN go down on you?
So I've had this discussion an awful lot with my customers in the past, and when they say we are going to go with the SAN, and then we start talking about the things we have to talk about in the design of the SAN. How many of you have direct control over the LUNs and what disks get used how on the SANs and things like that? Versus how many of you contract that out to the SAN vendor? So my customer in the U.S. public sector, so the government in the U.S., they farm that out. They don't have control over that at all when they have SANs. They have to give the guidance to the SAN vendor themselves. So what we talk about a lot of times is a whole list of things here. We talk about the shared storage. Let's make sure that when we put databases out there, you don't have two databases on the same disk, on the same LUN. Or if you do, make sure that it's not two databases that are two copies of one database on the same shared infrastructure. Let's make sure that we have the right number of copies. The SAN vendors want to introduce deduplication, and we really recommend against that. This is one of those cases where we have a difference with some of our SAN vendors where we say, really, no, you shouldn't do deduplication. We don't really support that. It's recommended strongly against doing deduplication. And it's because we are very careful on how we put data on the databases, and deduplication moves things around when it's done in the background. We don't do duplication ourselves anymore, but the SANs try to do that for you, and we think that's not necessary. The DB and log separation, all these things that are in this list, you still need to think about. But the key point here is, if all else fails, you got to run jet stress. And we have guidance in the jet stress field guide around what to do on a SAN. You have to do jet stress right. We have guidance around what to do on a SAN. This web link here is the storage guidance, and it talks about the things that are required for storage. And that can be applied to SAN as well as it can be applied to direct attached storage. Just make sure you have those 64K NTFS allocation units and the 256K stripe sizes, and those things that are listed here on this page are extremely important. And that jet stress field guide, I don't care what you're deploying, the jet stress field guide needs to be followed, right? It talks about things like when you're testing your SAN, you need to pull a disk and do a rebuild and make sure you still get availability numbers that are right during the rebuild. Make sure your performance numbers are right during the rebuild, right? So you understand what's going on when the SAN has to have that rebuild. The idea is the disk is going to fail. We know that. The SAN builds it in to where it's transparent to you. Exchange builds it in to where it's somewhat transparent to you. You do have to swap the drive out and do a database reseed and things like that, but it should be transparent to the user, if not transparent to you. Even on a SAN, it's not really transparent to all the administrators, but you need to understand how a rebuild is going to affect your performance. And if you don't do that during your jet stress, then that's going to be a challenge.
So Robert focused on the rebuild thing, which is one of the elements here, and this honestly refers to the different RAID configurations that you might choose for your solution. What I would like you to think about is, again, I already used that analogy. Exchange gives you the RAID concept at the application level. So think about what RAID is. It's just a second copy of the storage that you deploy there, but it's connected to the same server. So you can end up with the design number 1 on this page, which is really bad because you have two RAIDed pieces of storage here. So in total, you have 4 copies of your data, but you only have 2 servers. So your level of redundancy when it comes to the servers and the services that are running on them is very low. Instead, you could deploy options like option number 1, which is better, but still not good because now you introduce difference in how your data centers are configured, active data center versus the DR data center, and we would prefer to treat them equally. Or you could just use the best example, which is depicted on the picture below. Again, count the disks. There is equal amount of storage that you're physically allocating for your exchange, but you're getting much better redundancy at the server and the service level out there. So now, when we're saying don't use RAID, and we're saying that our best practice is to use JBOD, we have to be a little bit cautious, because usually when people say JBOD, they do think that JBOD is something where you just pass the signals from the disk straight through to the operating system, and you can use the RAID-less HBA card for that. Not really. We absolutely do require cache on the controller, and from that regard, this is JBOD, but it's still configured as a RAID, so you take basically each disk in this JBOD and you configure it as RAID 0, and the only reason you do that is to be able to take advantage of the controller caching for this. If you don't do controller caching, the results are just astonishing. Exactly the same storage on the server that is able to give you 90 IOPS per disk. If you use the caching and you configured controller properly, exactly the same storage, if you disable the cache, you would get 3-4 IOPS per spindle, and your jet stress test will fail miserably, and your exchange performance will go down.
Yeah, Boris learned this the hard way with one of our customers. So
yeah, basically several of our large customers unfortunately run into those issues because they misunderstood that JBOD guidance, and they thought that they don't need any RAID controller for their disk. They unfortunately learned their lessons the hard way, so don't follow their bad examples. There are lots of other very interesting things there. Like, for example, some controllers, they give a dangerous option of pinned cache. So when one hard drive fails on the controller, it automatically freezes the cache and switches all other drives from the write-back mode into the write-through mode, and then your performance goes down again. So be careful about the specific functionality and configuration on the RAID controller. It all needs to be done right. Now, finally, the last big consideration and topic of discussion is usually thin provisioning. What if I don't have all this storage for all these gigantic mailboxes? I'm greedy and I don't want to buy all the storage upfront. I mean, my users today only have like, what, 50 megabytes of data in their mailboxes. Why am I going to buy this 10 gigabytes of storage per mailbox to give them these larger mailboxes? Technically, yeah, you can do that, but there's a very serious risk associated with it, because the capacity of the mailbox, the users might not use right away, but performance is what stays the same. Performance does not depend on the size of the mailbox. It depends on the user activity, on the operations that user is doing, and this is not something that changes. So if you allocate less storage, that means you allocate less performance as well, and that's one big thing. And the second biggest problem with thin provisioning is that when it starts growing, and when it goes close to the limits, to the hardware limits that you have there, you have to be able to react fast. And we unfortunately had seen way too many examples of when the customers are not capable of this operation excellence, and they run into problems with running out of disk space on their Exchange servers. All it takes is just some unexpected mail storm or somebody sending a very nice, beautiful attachment of their kittens to the entire company to enjoy, right?
Yeah, we use the term on the slide here of operational challenge, which is very nice and politically correct. But the bottom line is that what you're introducing is you're introducing an operational complexity. And back what we said earlier, complexity brings risk. So you're introducing risk into your operational organization here. Sure, you can get it deployed, and it deploys just fine, but then operationally, a year down the road when you start filling the disks faster than you thought, can you buy those disks as quickly as you thought? Maybe there was a run on disks from some big cloud vendor, and they bought all the disks that your vendor had available to them, and you can't get the disks as quickly as you thought, and all of a sudden your disks are full. And that's a risk you're bringing to your system, so you need to watch that.
So that is why our final kind of recommendation and best practice and the ideal server platform that we are using ourselves in the service, and we would love to see you to use for your Exchange infrastructure, is looking like this. It's the simplest possible storage. We are not using even the separate storage enclosure, just internal disks right inside the server chassis. These disks are large because we want large mailboxes, right? So we are currently using 8 and 10 terabyte mailboxes there in the storage, and we'll switch to the bigger ones as soon as they are widely available. And you allocate certain number of drives for the Exchange databases. You keep 2 of the disks for the operating system and the Exchange bits, and of course that particular part you protect with RAID, because it's not a DAG, right? You don't have like database copies for your system partition, so that's why right there. And then you have at least 1 disk, or depending on how many disks you're attaching, maybe more, as the hot spare, to take advantage of the Exchange auto-reseed feature and allow Exchange to replace your drives automatically, which really, literally makes it operate like a RAID with automatic recovery, if you will. So this is the platform we would like you to deploy on. Okay, with that, we're switching to a different topic now, and let's talk about availability and site resilience, right? So all this high availability that we need is really to address what happens if something happens, right? So just in case I want to avoid getting into confusing situation here on stage, I would probably better wear the belt and the suspenders just in case. So what aspects of high availability are most frequently questioned? The first and very frequent is how to stretch your DAG. Can I deploy a DAG across 3 sites? Why is Microsoft telling me to use 2? Well, the reason is really simple. We're trying again to reduce complexity. Because DAG requires constant communications between all members of the DAG. So if you have 3 sites, you have more network links that you need to maintain. 3 sites is 3 links connecting these 3 sites together. Whereas if you have 2 sites, you only have 1 link connecting them together. So you have much higher probability of 1 link failing, and then things just start happening with your DAG. I don't have time to dive deeper into it. Have a link on the slide that allows you to read some pretty interesting
How many of my Exchange administrators in the audience have full control over the network? So I've got a couple, right? For those of you that don't, how many of you have full trust that your routing people, that your network people are going to get it right every time? Yeah, I see like 3 or 4 hands.
That's
right?
what this is.
And that's really what this is all about, is if the routing's not right and one of those links goes down, your Exchange can go down too. You think you've got it right, but this is a complexity where you're depending on other people a lot of times, as we see here. Not always, obviously, but a lot of times you depend on the other people to do it. And if it goes down, if the routing goes down wrong, your Exchange can go out. And that's really the complexity we're bringing to play here when you stretch it across 3 DAGs.
So what do you do if you still have sites? You have a lot of data centers. You want to use them, obviously, right? You don't want them to sit there doing nothing. So what do you do if you have, let's say, 3 sites? You can deploy pairs of DAGs so that each DAG connects 2 of these sites, and then you deploy another DAG that connects 2 other sites, so you end up with something like this. And of course, your users from the user locations, they connect just to the corporate MPLS network, and then that network routes them to whatever client access servers are in any of those DAGs, and then the user connection is proxied to the box servers in there. Now, because the CAS role, the client access server role, and I'm talking about the logical role, not the physical, right? It's decoupled from the mailbox. Does it really matter where the users connect to, which of the servers there? Because their mailbox could be somewhere along these 3 data centers. Does it matter where the users connect to? Well, it might matter, it might not. And it depends on how the network is configured, right? If let's say you have 2 data centers for the simplicity of an example, right? If there is no difference how your users connect, if the users have no preference, if they have equal connectivity to both of these data centers, then definitely our preferred model, architecture and design model, is unbound service model. So you could use single unified namespace across both of these sites. You could use geo-load balancing or just DNS round robin to route user connections between those sites. And then they will be proxied to the user mailbox location anyway. So it really doesn't matter for the users which site to connect to. In the older Exchange versions on 2010, where we did not fully support this consolidated namespace, you had to use bound service model, where the user have the preferred data center that they would need to connect to. And this might still be true in some environments if you don't have this symmetric kind of network environment where the users don't have the connectivity preference. If your users are, let's say, in California and you have a data center in San Jose with very good connectivity to this data center, probably you prefer users to connect to that data center, especially if the other data center, I don't know, is in Florida and you don't have a good connectivity from California user locations to Florida. Some companies have that. So you have to choose. Our best practice, again, is the unbound service model, but it might depend on your network. So the network is the critical success factor and one of those critical dependencies for the Exchange solution. Now, finally, what happens at the back end, so we just discussed how the users connect to the client access services. What happens at the back end is how your database copies are distributed. And that's where Exchange Calculator can help you a lot, because in the Exchange Calculator, we automatically create the database copy layout for you that guarantees even distribution of the database copies across the available servers, and actually it does much more. It optimizes the way how Exchange behaves if something happens. Let's say, like, if server 3 fails on the middle slide, on the middle picture here, you can see that all the databases from that server are equally distributed across the surviving servers so that you have equal load on the remaining servers in the DAG. If another server fails, those copies, database copies from that server, again, will be equally failed over across the remaining servers. So at all times, you would have the symmetric, even distribution of load across Exchange servers in the DAG. So that is why it's important.
But when you have your more complex environments, you still need to think about these layouts, right? So across the top, it says server, so which server is failing. And it tells us how that's going to fail over. Well, think about the fact that sometimes when you have these blade servers or a virtualization model, if you have one server, one physical server go down or one blade chassis go down, what is that going to do in this model as well? You need to think about that as you lay out where your servers go in those physical implementations. When you're on a SAN where it says disk 1, disk 2, you may not be on a disk per se, as you would in a JBOD, direct attached storage type model. You need to think about your LUNs and how when a given LUN goes down, if you lose a disk or something like that, how that's going to impact the other databases. So you can apply this even though you're not using the PA model. You might be able to apply this as well, and you need to think about that and think about how it applies to your more complex scenario as well.
So even when you have all these database copies and you have all this native data protection, what do you do about your backups? What are those backups? What do you need them for? This is kind of the frequently asked question, and you're saying that, I don't know really. I've been doing Exchange for the last 10 to 15 years. I was always doing. How would you live without the backups? How would you get your data back? Okay, so it all depends on how you treat your backups, what you use them for, and how you implement them. You know that in Office 365 we don't use backups. We use the native data protection. We rely on this database copies for highly available copies plus the lagged copy that we have there in the cloud, and they all are physically stored in different locations. So there's a very high level of redundancy and independency on this service. So if you think of the backup, it's just another copy of the data that is hard to restore. You technically, what is the backup? You just take your database and you save it as a different format of data with some different file extension, I don't know, BKF instead of the EDB and stuff like that. And then it takes a lot of time and dedicated special software and sometimes hardware to restore this data back and get the protection you need. Granted, there are scenarios that you address here, but what are those scenarios? Because in Exchange, within Exchange, there are many different native mechanisms to address most, if not all, of those scenarios. Single item recovery is one of them. Lagged copy is the other one. Safety net is the third one. So depending on what are your actual needs while you were doing backups, it might appear that you actually don't need it anymore because Exchange addresses all of the scenarios natively out of the box. And if it doesn't, well, then that's a deeper conversation, of course.
Now, what about the situations where you or your customer actually does say we need support backup? So there is guidance out there, right? Some of the guidance comes from us, obviously, some of the guidance is not. DPM is supported. DPM is a Microsoft product, so we do provide guidance on how to back up Exchange with that. Very specific versions listed here on the page are supported with DPM. We don't provide any support or guidance for third parties. We never do. I mean, this is just part of our support thing. We don't own it. We can't write the guidance for those. We can give you guidance on what that interface is. We can say, well, you should be using your VSS backups and things like that when you're doing these backups. But that guidance has to come from those third parties. And you need to remember, your backup media is just as important as your online media, right? Those disks or tapes that you back up to, you have to protect them the same way you would protect your online databases and the servers you have, right? And then remember that brick level backup, that brick level recovery challenge. There's a little bit of guidance down there, recovery to the original folders, a new thing that's coming out, preserving DLs and BCC recipients and things like that. These are very things you need to think about if you're doing these backups, especially if you're in a compliance type scenario. You have to be able to preserve things like BCC recipients and things like that, right? So you have to remember about these things as you go on.
And we are able to address most, if not all of these things natively, including the DL membership, including the BCCs and all that stuff. So the other challenge usually there about the protection of the data is the security. So how do I encrypt my data at rest? How do I ensure that it is well protected? And honestly, sometimes it comes to the absurd in some conversations with the customers, because seriously, if you think about what is exactly the threat scenario that you are protecting against, because usually if you don't want to get into operational nightmare, you configure your BitLocker so that your disks are automatically unlocked on the server start. And then the actual threat scenario that you're protecting against is somebody physically walking into your data center, grabbing the server out of the server rack, because grabbing just the disk would not be sufficient, it's encrypted, grabbing the server out of the server rack and walking with this server and associated storage out of this physical data center onto the street. If you're seriously addressing that kind of threat scenario, you probably have much bigger problems than the disk encryption.
How many of you have your servers in a closet somewhere? It's not locked. The administrator can get in, or the lady sitting at the front desk can actually get in there and see the servers, can touch the server.
And just for the record, I don't see any hands, which is great.
I have customers doing that, by the way. And so they're the ones that Boris says have serious problems, and they do. You need to secure those servers.
Still, the key point probably of this slide is that the backup is BitLocker is a very tricky kind of technology. You need to understand all the implications and intricacies, and you have to deploy it right. Probably the key here, the biggest challenge, is what happens when the disk fails in Exchange, and Exchange invokes auto-reseed mechanism to use the hot spare for the database reseed on that failed disk. That disk must be encrypted as well. How does BitLocker know that the disk has been just replaced by Exchange and it needs to encrypt it, and at which moment it needs to encrypt it? It needs to coordinate it all with Exchange. So that had been a huge challenge until recent updates. We implemented this new switch, which is AutoDAG BitLocker enabled, and it's absolutely must have if you want to deploy a BitLocker in the most painless possible way. And there are lots of other challenges, but again, if you follow the detailed guidance that we have on the Exchange team blog, you should be in the good shape. Now let's dive into another.
I've always loved this picture, man. This is one where someone said, hey, we can now do virtualization in a virtualization, right? So I can have a Windows 10 VM inside of a Windows server, and then I can do a virtualization on that Windows 10 VM. And this shows that kind of situation. And we always thought that was a pretty funny way to look at what virtualization can do for you.
But what it really does, it's adding those complexities, right? So this screenshot, which is obviously laughable, right? It's a virtual machine that is running inside the virtual machine in Hyper-V, which is in turn, this Hyper-V host is just a virtual machine on VMware. And that's where the screenshot was taken from. But point is, That brings a lot of complexities. And again, remember that key conceptual things. The brain isn't the solution itself. Exchange server, out of the box, provides all these redundancy capabilities and ability to fail the load over from one server to another automatically if something fails. And that something might be hardware, like storage, it might be software, like crashing services, all that kind of stuff. Honestly, technically, if you start going into very deep discussions with the virtualization folks, you would realize that there is really very few, if any, advantages from the functionality standpoint that virtualization brings to the table. Really nothing. The only honestly scenario that we could think of virtualization making sense is if you are a very small organization and you still have this beefy servers, because it's really hard today to buy a server with, like, I don't know, 32 gigs of memory, right? They all have a lot of cores and RAM right now on board. And you just don't want to waste this entire server just for running Exchange.
Yeah, you got to remember the complexities that it does bring. It brings a lot more complexities, and the picture at the bottom really talks a lot about all those complexities that get brought in by a virtualized environment. You just have to deal with all of those. You have to think about all those scenarios and make sure in your planning that you're taking it all into account, that you're following the guidance and things like that.
And remember the concepts. Remember what we talked about with regards to, yes, complexity. Robert keeps pressing on that, and I wholeheartedly agree.
Well, yeah, the concepts, like multiple servers on one physical server.
That's what I was after,
yeah,
right? So the availability and the failure domains. I don't know, my favorite example is this, like if you're hosting 3 Exchange virtual machines on one physical host, and all of your client connections are going through the load balancer into those 3 virtual machines on the same physical host, only to be physically, when they're actually using the computing resources on that host, they are all merging together and still sharing the same processor. Does that make any sense? So anyway, and think about failure domains that it creates, right? You have the host failure, you have all the virtual machines that are sitting on that host failing together with it, right? So if you don't deploy more than one Exchange virtual machine on one physical host, that would be obviously our guidance, then you deal with other factors, because what are those other virtual machines that you're hosting on the same host? SharePoint, SQL Server, whatever. So this is some unknown load that is created on that host, and this load are competing for the server resources, which creates additional design challenge for you. But in the first place, it does create significant extra complexity. So here's a nice example that we actually saw working with one of our big customers. They had a big outage of 50,000 mailboxes because the VMware host ran out of disk space, and they were trying to use the snapshots of Exchange VMs. Then they tried to move them to the other VMware host, and that didn't work well because they didn't shut down those VMs properly. So there was all kind of nightmare. By the end of this deep troubleshooting period, which took the entire weekend and more, they suddenly realized that the other mailboxes that were sitting at the same time on the cloud, they were in the hybrid configuration, didn't have any problems all this time.
So Boris really likes the suspenders in a belt story, right? But we think that also applies here when we talk about virtualization. A lot of times when our customers come in and they try to solve availability problems with virtualization, when you have Exchange servers, you're really doing a suspenders in a belt kind of thing. Exchange does really good with availability and site resilience, and if you're trying to leverage some of the VMware or even Hyper-V type solutions around availability instead of using the Exchange capabilities, a lot of times you're going to be reducing some of your availability capabilities as far as the Exchange team is concerned. Right? You want to minimize, I like the line here, try to minimize the use of virtualization bells and whistles, right? Exchange really expects server. It doesn't expect a virtualized server. And so it doesn't expect you to be moving that server around. It doesn't expect you to be doing vMotion or any of that kind of stuff. And we do have guidance around that.
So isn't virtualization something that we actually use there in Azure? Isn't that what we offer to the customers there? So running Exchange in the cloud means running Exchange virtualized in Azure, right? Wrong. The Azure cloud and running Exchange in Azure is not the Exchange cloud. Exchange cloud is Office 365, and Office 365 is deployed on physical hardware, following all these design principles and concepts that we explained and described before. Azure is like extension of your infrastructure into the cloud. So yes, we do support technically that you host your Exchange servers in Azure, but seriously, honestly, we don't recommend that. And the only scenarios that kind of really make sense for you to use with Azure is to host third-site witness. If you only have 2 data centers and you have to take advantage of the fully automated site failover with Exchange 2013, 2016, or maybe using Azure as for hosting the recipient management server after you migrated all of your mailboxes into the cloud and you're trying to decommission all of your Exchange infrastructure on premises, or maybe just use Azure as the lab environment, but using it as the real production Exchange environment is absolutely not something that we would recommend.
So Boris and I had a drinking contest last night, and I get to make the big announcement. He doesn't remember it, but I do. I firmly remember. Our big announcement today is around AWS. So, all right, just kidding. No, there's no big announcement. We still don't support it. We know there's a lot of customers out there that do run Exchange in AWS, and they have it running. They're claiming to be successful. There's a lot of information on the internet. None of it comes from Microsoft, right? They haven't gone through the SVVP. They're not one of our supported platforms. They say it works. That's fine. They can support it, right? Until they play ball with us around our supportability stance on virtualization platforms, we just can't support that. Right? I hate to say it that way, but it's out there. There's a lot of information on it. It's just remember where you're reading your support information. I do have people come to me and say, but I read that it's supported. Okay, but you read that on somebody else's documentation. If you didn't read it on TechNet, it's not ours. And like it said on that slide, TechNet is still your friend. Remember, that's where our support statements are.
So let's have a very quick pit stop on the compliance station. And just because this is the topic that surfaces more and more frequently lately, and lots of our customers are paying huge attention to compliance and what do we do to make sure that our data meets the regulatory compliance, how we ensure that this data is not modified or changed in any malicious way, and all the stuff like that.
So our little joke was, but her emails, right? So, because that was kind of in the news quite a bit. And here recently, it could have been changed to their emails, apparently, because there's an awful lot of other people doing their emails where they shouldn't have. And they should have all known better.
So the compliance is in the spotlight now. And how do you address that again? What does Exchange has to offer? And you know that since this is not as a feature that has as deep roots in the history as, let's say, storage design or something. It only started appearing in Exchange since 2010 timeframe. But it's quite robust now. We do have this new Security and Compliance Center in the cloud. So the key point probably is that you got to understand when you are culling the data for compliance purposes to provide this custodian data to the legal officers for forensic analysis and investigation, you got to understand that today in the modern world, you deal with a lot of data. It's one thing to use your old habits and say, hey, go ahead and bring me this 100 mailboxes into the PST files and we will do forensic analysis with them. If these mailboxes are 50 megabytes each, it's okay. I can do that for you. If these mailboxes are 50 gigabytes each, good luck with this PST file. So you really need to work closely with the legal folks, explain to them the benefits and capabilities of the Exchange solution, and maybe work still together in collaboration with the third-party products and offers that maybe they are using currently at the moment. But the point is that you need to do a culling in the product, in Exchange, using Exchange native features to make sure that when you export the data for further forensic analysis, it is already reduced data set that is workable, right? So you at least filter it, probably only export like 10% of the entire mailbox out there, and hopefully even less than that, right? So out of the 3 e-discovery features that usually comprise the e-discovery solution, it's the hold of the data, search for the data, and presentation of this data. Exchange is perfectly capable of addressing the first 2, right? You can impose all different sorts of holds with quite sophisticated criteria within Exchange. You can do the culling and perform the search and export the data. And only the last portion, kind of deep forensic analysis using the standards and legal requirements from different legal teams, is probably not something that we fully address in the product right now. So this is really a short pit stop. Now, another interesting topic is the network. Because, okay, let's say you used our best practice and you deployed Exchange on the direct attached storage, so life is good on the storage, you don't have any complaints. Our #1 source of the critical situations and support cases in CSS after kind of the world adopted our ideas about the direct attached storage, now it is the network. We usually see a lot of cases around the network and network failures because Exchange does depend on the network a lot. And of course, if you use devices like the one on this slide to connect your Exchange servers together, then you probably are in a little bit of trouble because that might not be sufficient to replicate all your databases properly. So typical challenges in the network is, okay, because our network is so poor and we have not enough bandwidth and we have too high latency, we would need to use the WAN deceleration devices to make sure that our network works better. And quite honestly, there are some workloads and some scenarios where those devices could be helpful and useful. But because of the Exchange nature of operations and because accesses to the Exchange databases out there and transmission of the data across the wire are so random, right? Hundreds and thousands of users are connecting at the random times and accessing the random portions of the data from different databases. The benefit of using this could probably be palpable only for offline address book downloads, just because offline address book is kind of same piece of data for all users there on the network. The other good example is to use the inspection devices. It's kind of funny out of, one of the customers that I worked with, they very aggressively pressed for us to ensure that we only use TLS 1.2 to transmit the data between the, let's say, 2 networks, and make sure that we are not using any lower protocols because they have security vulnerabilities. Guess what? One of the security vulnerabilities was to address the middleman problem, so that no device that you put in between and have it intercept the flow would be able to actually decrypt the traffic. So, okay, we followed that guidance, and then we had complaints with them. Oh, but now our Palo Alto devices could not decrypt that traffic and inspect it. So what happened? Guys, you just asked for it, right? So there could be a lot of networking challenges. One of the very popular topics lately, well, not lately, I mean, it's been a very popular topic since 2010 times, was how do you do replication between the Exchange databases and how does that impact user connectivity, right? In Exchange 2010, our best practice was to use dedicated replication networks. And in Exchange 2013 or 2016, we said, actually, you know what, that just adds extra complexity. Just use a single network card in each Exchange server and just put all the traffic through it. So this slide, I think, kind of summarizes it. So our best practice for Exchange 2010 is what that yellow box at the bottom shows: additional network card in each Exchange server, additional switch, and additional physical dedicated network between data centers.
How many of you actually had an additional physical switch with additional network between data centers? So a few, right? It's kind of expensive, isn't it, to do that? We've had a few customers. Boris and I worked on one big customer that did that. A lot of our customers would do something where they would play like they had that, but then it would actually go over the same network, right?
And that's also a key. Understand that the dedicated replication network only makes sense if it's really dedicated. If your Exchange server has 2 network cards that are connected to the 2 ports on the same switch, so that this network traffic is converged later on, and on the backbone it still flows as one piece of traffic, what's the point? There's no point at all. But if you want to keep your design simple and at the same time take advantage of the existing dedicated physical link between the data centers, you can do something that is shown on this slide in green. So you could just offload that IP routing logic on the router. So if the router sees that the packet is going from one Exchange server to the other Exchange server in the other data center, it would just use the static route that is configured there to route those packets across this dedicated physical link. And all the client connections, all the rest of the traffic will just flow over your, whatever you have at enterprise-wide, some corporate MPLS network or something, right? The benefit of this solution is that it would affect all server-to-server traffic, not only database replication, but also proxying of the client connections, SMTP submissions between the servers, and that's usually a good thing. It kind of isolates that network traffic and allows you to troubleshoot it easier, ensure that your client connectivity is not impacted in any way, shape, or form, and stuff like that. So some opportunities there, but still remember that the basic principle and the most fundamental principle, do not make it complex. That will be hard for you. That will not work well. With all that, finally, there are still some things to
down a few more
about.
things we need to think about, right? The general guidance beyond technology, right? Remember, it isn't all about technology. Everybody in this room is probably a technologist, and we all think that the technology is the easy part, right? Honestly, I do. I always did. But you still have to remember people and processes are in there as well. That's that triangle. You have to have them all, or nothing's going to work in the long run. Right? You still have to get your people trained. The more complex your environment is, if you've got the SAN and you've got the virtualization platform, you have to train your people on these things, and you have to train them to when they have to patch and how they manage those systems and all that kind of stuff, right? And when you have the processes, like change process, if you want to make a change, you have to think about what all is impacted. When you're going to change something on the SAN, is your Exchange system going to be impacted, or is it just a SQL system? And you have to think about those things, and you have to nail it down and make sure that everybody that's going to be impacted is notified about that. So those change management processes get more complex. One of the things that I like say is complexity begets complexity. The more complex you make the system, the more complex you're going to have to make the system after that, right? Think about virtualization. If you bring virtualization in, quite often, you know, not only you just have to manage that virtualization platform, but you start thinking about things like, well, I have more complex failure domains. I really start to have vendors pushing their HA and site resilience. We also start thinking about SANs at that point. Now I've got those SAN complexities I have to deal with as well. Not always, not every HA, not every virtualization platform is going to force us to have a SAN, but we start having those SAN things we have to, and now our failure domains are getting even bigger and all that, more failure domains, right? So it's where does it stop? You just keep adding more and more and more complexities in there, and you have to deal with those. Right? We do have guidance, we have support models, but you have to support those things, right?
I had a good example one time when I worked with one of my customers, right? So when you typically place your Exchange servers in the data center and you are the large organization, so you have multiple DAGs, you want to avoid failure domains, so you would place these servers into the actual racks in the data center, following this diagram over here, so that each rack would only have one server from each DAG in this physical rack connected to that physical network switch on top of this rack. That allows you to avoid failure domains that we were talking about previously, right? In this example, my customer did not have any control over how the servers are being placed in the data center, because that's a different team that is doing that, and the messaging team had no say in this design, so they didn't even know the servers from the same DAG are in the same rack or they are not. Now they needed to address the challenge with what happens if you lose the network switch on the top of this rack, because that becomes now a failure domain. You would lose all the servers from the DAG that are in that same network rack. So they had to install a second network card in the Exchange and configure the network teaming on these network cards to address the switch problem. See how one design, one flow, one problem in the design that they did at the early stage forced them to do something that contradicts our best practices and introduces complexity in their design.
So we're down under a minute left, so let's go on to the next slide. So this shows really kind of a support model where that center circle is Exchange Online. That's the most supported situation we have at Microsoft. As you go out, you get to the PA and you get to some of the Exchange on-premises recommended best practices. You get after that red circle, man, it's red for a reason. That's where we kind of say, it kind of works, right? Yeah, maybe you can make it work on AWS, but that's well outside our support boundaries. And when you start getting out into that, you're starting to get into a place where you don't want to be. So try to remember to stay as close to that center circle as you can as far as your support statements are concerned. And if you can't do it right, maybe you need to go to Office 365. Of course, we have to put that statement in there.
And then your kitten will be happy.
All right, everybody, thanks for coming. About it. Remember to do your evaluations. We appreciate everybody coming out this early after the big party last night, and make sure that you go back and review some of these sessions. I don't think there's much of anything left after this one. There's a session I think I'm going to go attend here in a little bit, but most of these have already happened, but you should be able to go back and watch these if you haven't seen them already. Thanks everyone for coming out this morning.
Thank you, everybody.